All right, good afternoon, ladies and gentlemen. Thank you all so much for joining us today. On behalf of AUVSI, I'm very pleased to welcome you to today's webinar, Visualizing Airspace Situational Awareness for Large-Scale BVLOS UAV Operations using the Ground-Based Surveillance System, Casia G. My name is Shannon Walker, and I am the Program Manager here at AUVSI and host for today's webinar. Before we get started, we have a couple of those housekeeping items we always like to go over before the presentations. So all of the attendee lines will remain muted throughout today's broadcast. A recording of the webinar is in progress, and it will be emailed out to all attendees along with a copy of the slide deck within the next week or so. If you're listening today and you need any assistance, please send a note to the webinar leader using the chat box on the right side of your screen. If you don't see the chat box yet, just click that little chat bubble icon that's located at the bottom right-hand side of the screen, and that should open up the chat box panel. Please note that all links featured in the slides today will be shared through the chat during the presentation. So after our presentation, we're going to open up the session for Q&A. So attendees, you are encouraged to submit those questions at any time throughout the webinar using the Q&A box on the right side of your screen. But the questions are going to be saved to be answered towards the end of the presentation. And please note, this is a different box than the chat. So just make sure that you're submitting all of your content questions for our speakers using the Q&A panel, which can be found directly underneath the chat panel. And another quick note for attendees, you can change your screen view by clicking that layout icon found in the upper right-hand corner of the slide screen. So go ahead and play around with that and find the view that works the best for you. Okay, let's get started. We would very much like to welcome back and thank our sponsors for today, Kongsberg Geospatial. We are very excited to kick off with two excellent speakers, Rex Hayes, Director of Unmanned Systems at Kongsberg Geospatial, and Jason Hardy-Smith, the Vice President of Product at Iris Automation. So this webinar, as we said, is brought to you by Kongsberg Geospatial, which is a subsidiary of the Norwegian company Kongsberg Defence and Aerospace. Kongsberg Geospatial is headquartered in Ottawa, Canada, and creates mapping and geospatial technology for a range of mission-critical applications, including defense systems, air traffic control, and airspace awareness software for unmanned systems. Kongsberg Geospatial are the creators of the TerraLens Real-Time Geospatial SDK and Iris UXS, a ground control station and airspace visualization system for safely operating UAVs behind visual line of sight. Kongsberg Geospatial has been working to develop a standards-based system for recording, accessing, and comparing real-time and historical sensor data captured from unmanned systems. So back with us today is Rex Hayes, and Rex has been in the unmanned industry since his program management days while on active duty with the U.S. Coast Guard. As a helicopter pilot, he understood the huge potential of unmanned aircraft, and after retirement went into unmanned industry starting as a subject matter expert while at Booz Allen Hamilton, and then with Textron AAI as managing BD director for the Aerosonde and Orbiter UAVs. After Textron, Rex started his own company, assisting multiple companies with their unmanned goals and strategy. So Rex joined Kongsberg Geospatial last year as the U.S. unmanned rep, appreciative of the fact that the data in presenting that data was at the heart of most of the unmanned operations. So joining Rex today is Jason Hardy-Smith, a proven product management executive with 20 years of experience defining and driving product strategies and roadmaps in technology industries. Jason has owned the end-to-end product lifecycle of successful first-to-market products for companies including Oracle, Blue Roads, Bright Idea, and Isomorphic Software. He has built efficient, scalable, global product organizations from the ground up. Before starting his product management career, Jason was a software developer and received his Bachelor of Electronic and Electrical Engineering from the University of Glasgow. So Rex and Jason, we're thrilled to have you both with us today. We know we are in excellent hands, and with that, I will stop talking and hand it over to you.
Great. Shannon, thank you for the introductions. Jason, great to have you on this call with me today. Good afternoon for those on the Eastern time zone, and anywhere else you are, good day. It's funny, Shannon gave the comment about my Coast Guard days. So For those that have joined us previously, I'm usually giving these webinars from Philadelphia, and their show It's Always Sunny in Philadelphia. If you've ever seen that one with Danny DeVito was on. Well, I am actually in Tampa this week, and it's actually sunnier here in Tampa. So, and it's quite interesting. My first Coast Guard duty was flying out of Tampa, and I forgot how insanely hot it can get. So it's not only sunny, it's very hot here as well. But anyway, greetings from Tampa, Florida this week. We're going to go through the slides. We're going to talk about IRIS today, which is our geospatial situational awareness software. Jason's going to talk about IRIS automation, and there's no connection between the two except for the joint product we're doing. Just happen to both have the IRIS name, so you won't hopefully get confused on that. Jason will show a video. I will show a Casia G video, which is their ground-based detect and avoid system. And as Shannon said, then we'll open up to Q&As at the end. And without further ado, we'll start. I'd be remiss if I didn't go over the Kongsberg Geospatial history. We are 30 years old this year. We started as Gallium. We got acquired in 2006 from Kongsberg, which Shannon noted is our Norwegian parent company. Changed our name to Kongsberg Geospatial in 2012. And this just gives you a timeline of some of the things we've done since then. We started out with our core software as TerraLens, which I'll go into a little bit because that is the basis for a lot of our products we have. But as you can see through this timeline, I'm sorry, I have to put my glasses on to see, but some notable programs, the Terminal High Altitude Area Defense, or THAAD, for those that might know that, the Joint Battle Command Platform. We've dealt with Wedgetail. We're actually working with them again. The Joint Tactical Attack Controller, aviation traffic management systems, and Combats 21. I'll get into some of the other ones in this next slide just to kind of show you the depth and breadth that we have. So we are on the Navy Aegis weapon system. That's our TerraLens inside. It's almost like Intel inside. That was the cute thing for the laptops way back when. So TerraLens inside a lot of programs. We're on fast attack submarines, the Virginia class, Navy's air traffic management system. The NASAMS, which is the surface-to-air missile system, which has been exported to, I think, 13 countries now. That's going very well for us. We have the C2 display for that. Combat management display system on the Coast Guard National Security Cutter. Again, you always have to give a shout out to the Coast Guard. And then lastly, on the ground control station display for the Triton MQ-4. So I say that, and it dovetails nicely into the IRIS situational awareness, which is also an airspace deconfliction program. Again, if you heard this brief, we'll kind of expand upon it a little bit. So IRIS situational awareness, it has several areas from a fleet management side to an airspace management side. At its core, it's a situational awareness display, and I'll show you that. It's one common operational picture that can put everything into your operational area, and that could be aircraft that are known through ADS-B. It could be unknown aircraft. It could be drones. Again, AIS ships. It could be anything in your area. IRIS can ingest, and we can display that. We also can ingest GCS, and I'll show you that again with our DDS. So we can actually control aircraft from IRIS as well. There's a counter UAV component of that as well. With Jason's company, that has potential as well with their optical solution. And then lastly, we think on airspace management, we have a good place in the unmanned traffic management system. So what does IRIS do? So the TerraLens we talked about would be that, going from the ground up, would be that maps and imagery, the software development kit. IRIS ingests aeronautical information periodically. It takes in live data. It takes in ADS-B, can take in weather, traffic feeds, Harris NextGen. Again, it's kind of up to what the user wants. We also display our own aircraft position. That could be altitude path. And we put vectors in for show heading and where the projected path is. And then lastly, again, this is where Jason comes in with the Casia G program, is collision avoidance. We've taken optical, obviously, with them. We've taken radar. We can take LiDAR. Again, all ingested into IRIS and help with collision avoidance. Okay, so how do we do this? Data distribution service. So you have your data coming in, and that's the top feed. I don't know if you can see my mouse or not. But again, it's any aeronautical data. It's 80 which is going to be a new requirement for the FAA. Radars, I have to put one in there for optical, Jason, for you guys as part of the DAA. Take our own ship telemetry, which is the top right, and then we get services. You can get a detect and avoid service, and I'll show that on the video as well. You can get terrain queuing alerts. You can get airspace alerts. You can get vehicle alerts of any kind of collision. The one I didn't talk about is this top middle one on the top, other inputs. We specifically tailored Iris for the Casia G program. We're calling it the Casia G viewer, which has the optical 360-degree field of view, if you will, with ADS-B as well. So again, whatever the customer wants, we can always ingest that. Right now, so Iris has seen some good headways. I'm actually at a soft conference this week, which has applications, but on the commercial side, there's a lot of applications as well. We're currently in contract with 4 companies, from SkyDrop to Skyports, a few others that wanted to stay anonymous, which is fine. We have no problem doing that. We're in consultations with a 5th company right now, and hopefully we'll have news the next coming weeks about how that's proceeding as well. So from the commercial drone delivery side, we see a lot of application on that. Okay, so Iris. Iris is not just a user interface or UI. It's definitely a situational awareness. I stole this slide from one of our engineers because I think it kind of sums it up nicely. We have adapters, we have translators, we have sensor integration, and that's key. What we take is we take all these disparate sensors, if you will, and we correlate the information. So if we have multiple tracks from radar or from Jason's optical system, you're not going to get separate tracks as the camera picks it up. We'll actually correlate that so the user only sees the one track. We have algorithms that will say, yeah, this is the most valid track that you need to watch and follow. So we have a correlator in there, which is huge. Again, mission planning now has come out. If anyone saw us at AUVSI, engineers came up with a new mission planning window that we're using as well. And our engineer surprised me. I didn't know we had that until I showed up at AUVSI, and I said, "What is this?" So, sometimes BD and engineering don't quite talk as often as they should. I'm going to catch grief from Joe, and I know this. Again, data's passed over the DDS, and services come out with that. We have a thick client as well, and Iris can be as web viewer. Next one. So why did we do Iris? Again, you see this one at an airport, and you should be worried, saying, "Boy, this one person gets overwhelmed with all the different sensors, all the different screens out there." Iris gives you the one screen, one common. This is an Iris display. So the right-hand side is a 3D graphic of your area in question or the area that you want to work in. Casia G viewer has that as well. On the middle or the left side is your 2D version. As you can see, you have different layers there. Iris has, we can put in airspace layers, we can put in obstacle layers. If there's any avoid areas, we can put that in as well. And then we have multiple tracks, if you can make that out. Sorry, it's a little bit of a busy slide, but when you get the presentation, you can see it. Again, if it's an ADS-B aircraft, we'll pick that up. We'll have the vector data on where it is, where it's been, and where it's going. And then with Jason's Casia G ground detect system, we'll actually be able to pick up uncooperating aircraft as well. And we'll mark those out and keep those in track as well. Left-hand side, we do have full motion video. You can have mission logs. Any of those cards are all adjustable as well. And you can pull those in and pull those out as you see fit. Okay, so the Casia G viewer, again, mentioned it's based on TerraLens. It's based on Iris, and it's a tailored optical detect and avoid system. Again, it uses the TerraLens software development kit, and it uses the Iris's unmanned interface and unmanned experience. So for those clients that have used Iris in the past, they're going to know exactly where everything is and how it works and what it looks like. And it's tailored for Casia Gs, and I don't want to steal Jason's thunder here, but their optical 365 detect and avoid system. What our engineers did as well is we put a display or an alert around the range of the Casia G, so you don't have to watch it the full time. If an aircraft, cooperating or uncooperative, comes in there, you'll get an audio and a visual alert as well, so that will help with that. Lastly, again, displays cooperating aircraft and non-cooperating aircraft. All right, so I'm going to turn this over to Jason now. He's going to go through his deck, and then he has a video in there as well. So we'll take a break and show that video. Jason, all yours.
Thanks much, Rex. Big thanks to Rex, Chris, Paige, and the whole Kongsberg team for giving me the opportunity to speak today. Thanks much. And also to Shannon and the whole AUVSI team for hosting this webinar. Again, I'm Jason Hurley-Smith from Iris Automation. Iris, not to be confused with Rex's Iris. I'll try and make that clear as we go through this presentation. If you want to jump to the next slide, Rex, please. So start off a little bit about Iris Automation. We've been around for about 6 years. We're headquartered in Reno, Nevada, primarily because there's really good places for us to test our solutions there, kind of out in the desert. I'm based in San Francisco. And what we do is we develop computer vision systems. Like Rex said, they're all called Casia. Casia G is our ground-based one. But these systems are basically designed to make aviation safer. So, what really is a computer vision system? I think everybody's pretty familiar now with the concept of self-driving cars and kind of how they work. We're basically doing the same thing, but for airspace, right? We're automating the human eyeball. We have a bunch of cameras that stream video to computing power, and we use artificial intelligence to understand basically what's going on around us in the airspace. And we do that primarily so that we can detect non-cooperative air traffic, that doesn't have a transponder, or it's not broadcasting ADS-B. So that's the stuff that we really worry about, right? And we want to do that in an automated way so that we can have automated avoidance maneuvers, or at least avoidance can be executed really quickly and keep your drone operation safe. So we have a bunch of different flavors of products. We have products for commercial drones that actually go on board the drones. So talk a bit more about them in a minute. But basically allow you to fly autonomously beyond visual line of sight and detect any air traffic and autonomously avoid it. We have ground-based systems, and that's what we're going to be talking about most today. Again, same thing, detecting non-cooperative traffic, and then in this case, we'll be sending alerts to Rex's Casia G viewer, which is part of Rex's Iris system. We also have general aviation products, so through a partnership with Becker Aviation. You can think of these basically, if you think of a helicopter pilot fighting fires, and there's a lot of aircraft around about them, through our Casia products, we can give them awareness to all that air traffic and prevent some of those, converging collisions that seem to more frequently happen these days. Lastly, we're also working with a number of advanced air mobility or air taxi platforms. Recently, we're working with a bunch of them, but we recently announced our Embraer Eve collaboration, and basically helping to make their operations safer. So kind of a range of products, but at the core of it, pretty much the same software and very similar hardware across the range of products. Next slide, please. So I'm going to get into details about how our software works and the performance and how you use it and all that kind of stuff. But, I wanted to start off talking about, how we work with some of the standards bodies that are out there. We are really trying to move the industry forward as a whole. Computer vision and artificial intelligence is pretty new technology, especially when you compare it against something like radar, right? That's been around, since kind of, I guess, second World War. Computer vision's evolving at a really, really high rate. And so we're working with, ASTM, RTCA, EUROCAE, basically standards bodies around the world, help them kind of understand the technologies, the possibilities, and help them work to define standards that will help us get these technologies out there and, in your hands, so that we can basically make airspace safer and make BVLOS a much kind of common occurrence. Next slide, please. We're also working with a bunch of the working groups out there, technology programs, a lot of them with the FAA, so their integration partner programs or IPPs. We work in FAA's Beyond program with a bunch of NASA's programs, and basically, you know, we're doing this around the world. Despite the fact that we're a pretty small company, you know, we feel it's important to kind of contribute and collaborate and help drive the industry as a whole forward. So with that said, I want to get into a little bit, you know, on the next slide, please, Rex, on, you know, why we're doing this, right? I think, you know, the vast majority of drone operators want to fly BVLOS, right, beyond visual line of sight. And because really that's when the safety and the full economic benefits of drones really kick in, right? You know, so if we take a power line example here, you know, if you get 1,000 miles, you got to inspect. Sure, you could go and do that by helicopter, right? But doing it by helicopter is quite dangerous. You know, those low altitude strikes against towers or trees or you know, power lines makes it a pretty dangerous operation. Now you could do it by drone within visual line of sight, but then you're kind of driving to the first location, unpacking the truck, getting set up, flying a couple of miles, coming back, packing up the truck again, driving a few miles down the road and kind of rinsing and repeating, right? It's not, you could hardly say it's sufficient, right? So also things like, you know, package delivery, right? You know, Amazon's really good at getting us packages really fast, but I think if we could get it in 30 minutes or an hour, you know, I don't think too many of us are going to say no to that. First responders, you know, delivering, you know, organs, drugs, defibrillators really fast. You know, speed is really of the essence, literally, you know, life and death. So, you know, I think, you know, the one other point in that is right now we see most operations, multiple operators flying a single drone. We really want to flip that on its head, right? And allow a single operator to fly multiple drones. We get those kind of economies of scale. Probably preaching to the choir with all of this, but I think it kind of sets the scene of what we're going to talk about. Next slide, please, Rex. So why can't we fly BVLOS? You know, there's technically no reason why we can't, right? You know, drones are great to fly. You know, we have the technology in drones to have them fly 100 miles, no problem. You know, C2 systems are good. Autopilots are way more than capable of, you know, setting a bunch of waypoints and having them just go and fly themselves. The problem really is the non-cooperative traffic out there, right? You know, the FAA, you know, if when planes are flying out there without ADS-B out, you know, basically it's see and be seen, right? The pilot can see the other aircraft because the aircraft is big enough and vice versa. When drones are out there, they're too small for pilots to see, so the pilots can't avoid them. And the remote operator, you know, since the non-cooperative traffic doesn't have ADS-B out, they don't know where they are, and that's where the issues potentially happen. So this is the problem that we've really been focused on solving for the last 6 years. Next slide, please. So we have a couple of onboard products. You know, these actually go on your drone. We have machine vision cameras, 1 to 6 of them, depending on the solution. And that's streaming video to graphical processing units. Graphical processing units are really, basically think of a really small but really high-powered computer on your drone. And onboard that GPU, graphical processing unit, are deep learning algorithms. So we're basically using artificial intelligence. So much the same way as a baby learns to identify, you know, different shapes, different objects, we've trained our algorithms to identify aircraft in the airspace. So if our system identifies an airspace, basically sees an aircraft in the airspace, it will understand what it is. Is it a helicopter, small plane? How is it moving? You know, are we likely to breach well clear? And if so, it will instruct the autopilot to autonomously perform an avoidance maneuver. It can also just send an alert to a remote pilot's ground station as well, ground control station, and they can manually make that avoidance maneuver since it will provide that situational awareness. Next slide, please. So here, I hope you can kind of get an idea from these pictures how the systems get integrated on the drone. On the left, we have our bigger 5-camera system. you can see 2 of the 3 cameras in the nose and 1 on each wing pointing backwards, and that allows us to see 360 degrees around the drone. The other image on the right is with a twin rotor. It's an Avidrone twin rotor. That has our smaller 1 camera system. You can kind of see the camera protruding out of the nose. And now I have a kind of short video just to give you an idea of how the system works. If you can play that now, Rex, if possible. If the video is not that clear during the webinar, the follow-up slides will actually be a much more higher resolution for everybody. This might just take a couple seconds to kick off. Okay, here we go. Now this is actually, it's not super clear on here, but we're actually on board a drone, and this is what our system sees. Video is a bit choppy, and I think the video is being actually cropped a little bit here. So yeah, I'll talk through it and you can view it later if possible, but the detection it's made is actually off screen. The video has been cropped a little too much. You'll see it come into field of view in a second. But basically, the system's detected an aircraft about 1.2 kilometers away. Yeah, this video actually didn't come across too well at all on the webinar, I'm afraid. But if you can watch it afterwards, you can see the system flying over the desert in Reno, and we make a detection of an aircraft about 1.2 kilometers away, and you can see it tracking it all the way through. Kind of gives you a bit of a feel for how the system works. We've been iterating on our system for quite a bit, and we've been getting various, and our customers have also been getting various approvals to fly BVLOS and EVLOS with our systems on board. Many of them without visual observers or other mitigations. X system, we got an approval up in Reno probably 2 months ago now. To fly without visual observers. We've flown 107 miles under that waiver. That particular one's in Class G airspace. I encourage you to go to the FAA's website and you can review some of these. But yeah, quite a lot of successes there. Inspecting pipelines, power lines. One of our key partners, Census, has had a lot of great success here in working with their customers like Soaring Eagle Technologies, for example, and yeah, so they've been basically eliminating visual observers wherever they can, and flying longer and longer distances with Casia 1 and Casia X systems on board. Next slide, please. So getting now to our ground-based system, which is really what we want to talk about today. The technology is very similar to what you see on board. In fact, it's exactly the same software. The hardware does actually vary a little bit, but essentially, we do have ADS-B receivers, but we're using our electro-optical systems, our cameras and compute power and deep learning algorithms to detect that non-cooperative traffic. So why would you use this? Well, you've seen some of the drones that we put our other systems on. They're a little bigger, right? I think the Saxon M14 with, fuel and, a sensor on board, plus our Casia X system, is pretty much getting close to that 55 pound Part 107 limit, right? So if you have something like a Skydio 2 or drone in the box, it's probably not going to carry it. Or if you're delivering packages, you might want to save that payload and not use it up, not use up any of the available payload for a detect and avoid system, right? So you can use a ground-based system. You can use one of them or many nodes to detect that non-cooperative traffic and essentially sanitize the airspace over your drone operation, and get that situational awareness and display all of that data through Rex's Casia G viewer. Next slide, please. So on the left, you can see what the Casia G system looks like. So yeah, a lot of people say it looks like WALL-E or Johnny 5 or even E.T. So this particular one has 5 cameras, and that lets you look all the way around. Each camera, these are machine vision cameras, so really high resolution, sending about 4K of data, about 5 frames every second. If you kind of contrast that with a visual observer, visual observer will stand and scan the sky looking for that non-cooperative traffic, scan a segment of the sky, and then turn and keep repeating that until they get 360-degree around, and then they'll repeat it. I'm not sure exactly how long that's going to take, maybe a minute, something like that. We scan the sky 5 times a second in 360 degrees looking for traffic. So, and then, we're very good at knowing where that traffic is. A visual observer kind of guesses. Our system can also stay outside in the heat or the cold all day, doesn't need breaks for lunch, doesn't get distracted or bored, and it kind of turns up for work every day, right? So some benefits kind of over a visual observer. So our system is going to detect an intruder, and it'll take about 300 milliseconds to send an alert to Rex's system, and then you'll hear that audible alert, visual alert, and then you can determine what you want to do. It might be that you want an automated avoidance maneuver to happen, or you might want your pilot to make a decision. We'll also send zoomed in images of that intruder aircraft, so that that will help you make decisions too. You'll know how fast it's going, what direction it's going in, and really gives you that great airspace awareness. Next slide, please. Here is a Casia G out in the wild. You can see it's detected a helicopter up in the top right of the screen. Essentially what we're doing is we're not only just detecting something and saying there's something over there, we're going to actually classify it as a helicopter, multi-rotor, tell you what direction it's going in, etc. We can detect something around a Cessna, it's kind of Cessna size, about 1.7 kilometers away on average. Kind of max would be 2.3, 2.4 kilometers. But the key here is that you will, you don't just have to use one node. You could use as many nodes as you want, and that can get you unlimited range. You can cover as big an area as you want. These are really easy to deploy. You can put them on something like a tripod, for example, telescopic pole if you have one of those trailers that you tow around. You can put it on a roof if you want to do a permanent installation on a pole, side of a building, that kind of a thing. We see companies doing it a bunch of different ways. There's the kind of disaster response type thing where you'll take it out, put it on a tripod or telescopic pole, or there's the more last mile package delivery where you're putting the systems out on a permanent basis across a large area. Next slide, please. So essentially what we are doing for each of these nodes, and here's a kind of, I think, a good image of Rex's system. You can see the 3D coverage of the Casia G system on the kind of left side of the screen, and you can see the altitude that the aircraft are flying at. You can see your own drone in there, but that red area is essentially the field of view of that Casia G system. So if you had multiple Casia G systems, you would see multiple of those 3D shapes, and we're going to be pushing detections of intruder aircraft. Could be ADS-B detections or electro-optical. And we'll also push the status of the Casia device. So if for some reason Casia stopped working, maybe somebody unplugged it or it got disconnect, the connection went down, then we would there would be no more heartbeats sent to Rex, and so the system would alert you to that. And also when there's an intruder, we can send those audible alerts, right? So even if you're not paying attention to the screen at that second, you'll get the audible alert in time to look in that direction. Okay, and so if you go to the next slide, please. With a single node, and this is a little bit of a eye chart. I'm not sure you're going to be able to see this in detail, so I'll talk through it. As I said, if you have a single node of a single Casia G node, we're going to detect something like around about the size of a Cessna, max of about 2.3, 2.4 kilometers away. If it's a 747, we'll detect it, I don't know, 20 miles away, something like that. Maybe several hundred meters, depending on the size of it. Our average detection rate is about 1.7 kilometers. And what we're really doing is giving you time to be able to react to any intruder. And then the blue kind of circle in the middle would be the area that you're going to operate your drone in. So this particular example of a single node might be good for you to, excuse me, do something like inspect a cell tower or inspect, maybe a bridge, for example. If you go to the next slide, if you wanted to do something that's more long linear, for example, a railway line or, sorry, I'm losing my voice a little bit, a railway line or maybe a power line, pipeline, you can string multiple of these together to create a corridor. And we're seeing a lot of companies doing that and, either co-locating these with drones in the box or using a larger platform to just, fly the entire, inspection. And then if you wanted to go to a larger area, next slide, please, you can add many more systems to cover essentially as large an area as you want. And what you can note with that is that you don't just get the circle of operational area for each Casia G, you get all the area in between too. So the area of operation really scales exponentially. You could, there's a lot of different ways you could implement this. For example, you could just have a circle of Casia Gs that sanitize a really large area that you want to sanitize. Next slide, please. So how do we know that Casia G works? We spend a lot of time, as I said at the start of the presentation, our headquarters are up in Reno. We specifically liked Reno because we have a close ties to the university there. In fact, the offices we use are rented to us as part of the Reno University Innovation Center. The airport there is also closely located to a lot of Bureau of Land Management land that we can fly in, and it's located next to an airport too. And so we have some GA aircraft that we fly against drones pretty much every single day to test the performance of our system and to collect data. We also fly, and we've done that, I think this slide is actually a little out of date. We've done about 20,000 encounters like that. Obviously we've had to build procedures and so on so that it's very safe. But it's a great way of showing how our system works and performs, and we collect that data and share it with civil aviation authorities around the world. Next slide, please. Give you an idea of how we test Casia G in the real world. This would be this example here is something that we would do over a couple of days. So and the kind of pink red shape, that's representing the field of view of one of the 5 cameras in a Casia G system. So we fly at the system at a number of different altitudes, so 100, 200, 300, 500 meters, a number of different velocities, at a number of different points in the field of view of the camera. And at each of those points, we fly at a bunch of different angles of incidences so that the system is seeing those intruder aircraft from really every possible different perspective. And from this, we can then understand things like what's our detection rate, our detection range, how well we track an aircraft throughout those encounters, and many other things, what might affect the performance of our system. And so, that's about 168 encounters. That's probably a couple of days, maybe a few days of flying, if all is good. But of course, we hit weather and fog, and up in Reno, we hit smoke a lot these days with all the fires. So, this kind of approach is, expensive and time consuming, and it's also in one location with, and if I want to get data against, let's say, haze, I can't necessarily get that on the day I want it, because Mother Nature may or may not cooperate that day. So to get around that and to also expand our set of data, we do a lot of simulation work. For the next slide, please. We've built simulators that can, in a photorealistic manner, basically, generate different environments. So it could be urban, could be desert, could be, fields or forests. We can vary the cloud cover. So you see some of these examples have a lot of clouds, some have scattered clouds. We can, have complete cloud cover. We can change the illumination. You can see on the bottom left, we have some haze. You can also see some different intruder aircraft. So we can vary the intruder aircraft. We can put many more intruder aircraft in the field of view that would be safe. And we can also put things or if there's a lot of trees blowing in the wind, or if it's really smoky, or if it's raining, what might happen to the performance of our system. So the real flights that we flew, we'll mimic them in this simulator. We can understand how good or how accurate our simulator is, and then we do thousands and millions of these simulations. We analyze all that data, and then we present it to the civil aviation authorities like the FAA. And this has been something we've been kind of, presenting very regularly, especially to the FAA. And we show them our successes, our failures, our roadmap, and then we share all of this performance data and analysis, where the system works well, where it does not. And if you go to the next slide, please, very, very recently for a Casia G product, we received a BVLOS waiver to be executed in Class G airspace up in Reno. Also, no visual observers as the sole mitigation for any intruder aircraft. So we're really excited with that. It has greatly increased the momentum, and the interest we're seeing from customers. Since we've got this approval from the FAA, we have flown this a number of times. In fact, I think we flew the operation 7 times yesterday, which is pretty exciting. And I think with sharing that success, I think that's pretty much all I have to share today. I think hand you back to Rex now, and I think we open it up for questions.
Jason, great. Thank you for the very informative brief, and congratulations on the FAA waiver. Let me go through, we have time. Let me go through a brief. This is at AUVSI. If anyone attended that, they could see this, but this will show you, here it is. So this will show you the UX UI of the Casia G viewer that we put out. And thank you for giving me credit for this software. My engineers are going to kill me. The Kongsberg Geospatial is definitely the one who put this all together. But again, this is 3D annotation. I'll talk a little bit over it. As Jason said, if you can see, and you'll have this to look at it later if you need to, but if you can see some of the tracks in the airspace that have ADS-B on it, great. Those are coming up through the ADS-B out. And if you see a Casia G, that's been the one that they're picking up. That's an uncooperative aircraft coming into space. So that red donut, if you will, is the Casia G limits, as Jason said, out to 1.7 kilometers. Again, you can, this is just showing some of the user interface things. You can change the color of it. You can change the alerts on it. What the engineers did is we actually put a circle around the outer realm of this. So if an aircraft comes in, you don't have to be paying attention. You can get an audio and visual cue on it. It shows all the vector data for the aircraft. It shows the history. It can show the altitude of where it is, where it's going. Again, it's all configurable. For those that are on the call that have actually worked with Iris before, you're going to say, yeah, it looks and feels just like Iris, and it does. Again, this is tailored just for the Casia G DAA. Again, you see the aircraft coming in the space, leaving the space. At the center of it is the actual Casia G system. You'll be able to do ranges from there. Again, a lot of the same user experience that we have in Iris is in this. As this plays on, you'll see the 2D map as well. You know, as Jason mentioned, if you do this and it is, you know, daisy chained, you'll be able to actually go out and see the rest of the Casia G donuts, if you will. So for that airspace that you want to keep deconflicted. I'll let this play on a little bit longer. And Shannon and Rachel will share the whole, it's a 4.5 minute video, so I have no problem sharing that with everybody. I probably won't show the whole thing here. Wait till we come up to the 2D side. So you have the aircraft that you're seeing in there. Okay, so brings in the 2D card now. And again, you can put, you know, any kind of layers you need to in there as well. So you do have the 2D, 3D. They're interchangeable. You can make one as big as you need to, or decrease it. You can pull it off to the side. Again, the exact same user experience that Iris gives the folks on that. And if you really need a detailed, we have a couple of customers that want a real detailed 3D view. We can arrange to have that as well. Right now, this is low res satellite imagery. If they do need high res, if you're working in the city, we do have a couple of vendors that we go through to offer that as well. I think I'll stop that here. Again, it's pretty straightforward. Cooperating, non-cooperative aircraft. If you come within the field of view for the Casia G, you will be detected. Again, get the vector data on the aircraft. I'll stop that here. Back to the webinar. You had Jason's contact info if you need it. Here's my contact info if you need. Again, it's Casia G is not mine, but I can point you in the right direction on that. So at this time, Shannon, I'll send it back to you. I don't know if we had any questions at all.
Oh, we do. The question box has been quite active, so we'll go ahead and jump right in and get to as many as we can in the about 12 minutes we've got left. Yeah. The first question, does Casia G guarantee that the pilot will get a waiver to fly BVLOS?
Yeah, I think this is probably one for me. So I think there's I know there are a lot of things involved in successfully getting a waiver. Certainly Casia G is one of them, but it's only one of many, right? You know, you have to look at, you know, the robustness of your platform. You have to look at training for your pilots and, you know, everybody involved and be able to demonstrate that. Your C2 system, you need to evaluate the air risk and ground risk. Are there any operations over people? And essentially put together a concept of operations. Likely after submission, you're going to get a, you know, request for information, for more information from the FAA that you need to respond to. So no, Casia G will not guarantee you a waiver, but it is, it can be a key part in that, right? You know, and we've shown that with getting our waiver without visual observers, but and certainly if you are going for a waiver with Casia G, you know, the FAA is more than familiar with Casia G now, and we can share all that performance data to go along with your submission. but there are some other considerations like those I mentioned that you'll need to be aware of and account for too.
All right, great, thank you. We had another question come in that asked, is all of this data available through the API as well?
Yeah, so for Casia G system, we're going to be sending. We basically use an MQTT broker. If everybody knows what that is, essentially a way of communicating the data out of our system. We have our own protocol for doing that, so we have a number of different messages for different things, right? A message for the intruder information, a message for the location of the Casia G. A message for things like the heartbeat to show that Casia G is running. I think there's also a question in the list about how data is stored. There are a bunch of ways to handle this. So for example, if you wanted to do something like categorize an airspace around somewhere that you want to have a drone operation and you want to use that data as input into your waiver application with the FAA, then you could basically store all of that data on the Casia device and upload it. We have some tools where you can upload it and analyze it. Or essentially you could store a subset of that data, or you could store essentially just be sending it in real time to to Kongsberg Geospatial Casia G viewer. And depending on how the Kongsberg tool is set up, I think you could save none of that historical data. I think you can save some portion of it. I think over to Rex on the kind of details of that. But needless to say, I think there's a lot of options there depending on what you want to do.
Great, thank you. Another question came in asking if you have any insight in the long-range radio solutions.
Is this long-range? I don't know. I feel like I might answer the wrong question here. Is this related to detecting drones, or are these long-range radio solutions to essentially detect transponders? If it's that, I have a limited understanding, so probably not the best person to answer the question, I think.
No problem. If the attendee that asked wants to follow up, feel free to in the Q&A box. And
yeah, I think with either of those two things, I know people that do and would give much better answers than me, so I would be happy to share that if the person asked the question follow up with me.
Again, I don't know who asked, but it might be an RF detection question, I'm going to guess. I don't know.
That's what I was thinking. It was either RF detection of drones, or there's also some radio frequency detections to try and that work at very long range to detect transponders from aircrafts that are not broadcasting ADS-B, and they basically do I think it's multilateration across maybe 5 detectors to pinpoint the position of that aircraft. But I'm definitely not an expert in that space.
Yeah, and for the Casia G viewer, RF detection is not part of that. Iris, we can, if a user wants that, we can ingest RF if it's something along those lines. So.
And they did clarify, they said long range UAV solutions, if that helps.
It sounds like it's, again, and I don't want to speak for Jason, but the Casia G, the single node is limited to 1 kilometer plus. You'd have to daisy chain out if you want to get that, if you're using that system. And if it's an RF detection at long range, Iris can do that, but it's not part of this. It's not part of this solution.
Okay, perfect. Thank you so much. Do you plan to design a night version of Casia G?
Yeah, funnily enough, we are working on that. We were actually out collecting a lot of data last night across a lot of different types of sensors. So Sony has some really interesting low light sensors. We're looking at IR, rolling shutter and global shutter solutions, it's an R&D project for us right now. It's going to be a little bit away. You know, we are still at the early stages of the adoption of the daytime solution. So, you know, I think nighttime is going to come after that. But yeah, we are working on it, and you know, we will be getting that out as soon as we can. We do have a ways to go though.
All right, great, good to know. The next question we have asks, does the performance of an individual Casia G node increase as more nodes are nearby? So in other words, do the nearby nodes share tracking information?
Yeah, so the data has all been sent to a single location, and that is where the data is essentially shared, right? At this time, when we pick up an aircraft, and if it flies through different cameras on a single Casia G system, then we understand that it's the same aircraft and we assign it the same ID. We're working on assigning that same intruder ID when it flies to the next Casia G node. But that's something that could potentially be done in the Kongsberg system just now. So if that, and with that enhancement, then that would be achievable just now. That makes sense.
Yeah, it does. Thank you. Another question that has come in asks, or starts with a statement. So range estimation is the challenge with any passive sensor. And this attendee understands that you use the AI ML to classify the target and through that estimate the range. Did the FAA have problems accepting the range estimation since it was based on AI and ML, or does the algorithm err to the conservative side when the classification is not clear?
Yeah, so I guess there's quite a lot in that answer. So yeah, we're a monocular system. So, if you think we have two eyes in our head, right, and that enables us to judge distance pretty well. So given we do have multiple cameras, but they're looking in different directions. So from a single camera, if we detect something, we're determining what it is, right? Is a helicopter, is a small plane or whatever. And based on that, we kind of know the size of it. And based on how many pixels it takes up, we're able to kind of guess how far away it is. And we repeat this testing in different areas, different cloud cover, and with different intruder aircraft a lot, and take that data to, sorry, that's my really loud doorbell ringing in the background if people can hear that. And then we also simulate that data, right? We simulate that real world data, and then we, do gazillions of simulations. And our simulator is very conservative. In a simulator, it's very difficult to render, aircraft like a Cessna, more than about 1,500 meters away. So that by nature makes our analysis conservative. And then, we are just very transparent about what our range is. We build this into what we call our encounter simulations that we do about 1 million of for each waiver, for each drone type. We build in a lot of that error, and that, with all of that understanding, and with, we basically open the kimono as to where we're good and where we're bad. And I think also typically we'll do an avoidance maneuver as soon as we detect something. So in some ways, the range doesn't matter a great deal. What's important is knowing that there is actually something there in the first instance. So I don't know, that was quite a lot of data points, but I think it's kind of the collation of them that hopefully answers your question.
Great. Well, thank you. We are short on time, and we are not going to get through every question that came in, unfortunately. So we'll wrap with one final question, and then any closing comments that either of you would like to make. So the final question is, obviously Casia G can detect cooperative and non-cooperative traffic, but can it determine the weather remotely so that the pilot knows whether it's too windy to take off, for example?
Yeah, so, okay, on the wind thing, specifically, we're actually partnering with a company called True Weather to co-locate wind, moisture, lightning, other sensors directly with the Casia Gs. So that would definitely answer that question. We're also providing images from the Casia G, so you could potentially, be looking out and see a windsock or a tree blowing in the wind to detect wind. We're also have been working a lot on being able to detect different kinds of visibility. So, for example, is it hazy or smoky and things like that that might affect visibility. Oh, the weather systems from True Weather that we'll co-locate as well. And this, I think, is really pretty interesting, pretty helpful to be able to detect cloud ceiling as well. So, and that's something that I think you can see from just the video of the Casia G system to how low the cloud is in a particular day and whether or not you feel it's safe to launch.
All right, well, perfect. Well, let me allow Rex and Jason any closing thoughts before we wrap for today.
Good. Jason, please go ahead.
Oh, thanks, Rex. Just like to say thanks again to Rex and team and Shannon and team for having me on to present today. And thanks for the thoughtful questions as well. I'll follow up on any I haven't responded to. And thanks for everybody that took the time to listen in today. I really appreciate it. Thank you.
Yeah, and I want to say, Shannon, Rachel, thank you. Great job. Thank you to AUVSI for hosting this. Thanks to Iris Automation, our teammate on this, and Deborah. I saw Lori's on the call as well. So Jason, you, Lori, thanks. You've been great to work with, and we look forward to some great stuff in the future.
Absolutely. Well, I'd like to keep the thanks going and say on behalf of AUVSI, we'd like to thank you, Rex and Jason, for this excellent presentation and this great discussion that we've had today. So attendees, as a reminder, you will receive a link to access the webinar recording along with a copy of the slide deck within the next week or so. And so again, we'd like to thank Kongsberg Geospatial for their generous support of today's webinar. And be sure to check back frequently to see our future webinar offerings, including some upcoming Kongsberg Geospatial webinars that we are tentatively scheduled to hold on September 21st and November 9th. So to look those up and to register for those, you just visit auvsi.org, click on events, and then webinars. So if you have any additional questions or comments, please email us at education@auvsi.org. And lastly, today's program is copyrighted by AUVSI with all rights reserved. So thank you all for joining us today, and we hope you have a wonderful rest of your afternoon.